Hi everyone, so today our lesson was all about rational functions. And what rational function is really focused on is being able to simplify fractions and being able to factor out a GCF. So before we go into actually learning what a rational function is, we are just going to do some intro stuff with simplifying fractions and, like I said, greatest common factor. So these are super easy, right? How we simplify fraction is just getting it to its simplest form, right? That's all that means. So when looking at this first fraction here, we have 9 over 18. My greatest common factor, or the biggest number that fits into both of those, is 9. So what I would do is just divide the top and divide the bottom by 9 to just get me 1/2. Okay, so this is how we simplify fractions. So on this next one, for 12 and 30, I have to think, what's the biggest number that fits into those? And I know that 3 fits into them, but I also know that 6 fits into both of those numbers. And 6 would be my greatest common factor. So if I divide both of these by 6, I would get 2 over 5. Okay? Now, I want you to try the next 3 on your own. So go ahead and pause this video. I know it's early, but pause it and just kind of reduce those because we learned this a long time ago. All right? So pause and try those 3. All right, now that you're back, we're just going to go over the answers, okay? So looking at 5 over 25, my greatest common factor is 5. So I'm going to divide each of these by 5, and I'm going to get 1 over 5 as my simplification, okay? The next one, I know that I could divide both 100 and 200 by 100, and once again, just gives me 1/2. Okay, and then the last one, I know that the greatest common factor is 8. So I'm dividing by 8, which will give me 1 over 4. Okay, so being able to divide and simplify things is going to be really important. Now, when we do it with rational functions, when we simplify, it's not going to be this easy. Okay, we're going to actually be simplifying binomials. And remember, this is what a binomial is up here. You can see I'm highlighting it in red, okay, or underlining it in red. So, we're going to have to know how to simplify, right? When things are the same, we could simplify. And that's really what that's saying is we can divide both of those numbers. There's a 6 in both of those numbers, so it's the same, okay? All right. What we're also going to need to know when we're going over rational functions is how to distribute or how to undistribute, or in this case, factor out a greatest common factor. Now, we did this a couple months ago, so we should remember how to do this. So remember, if I'm looking at example 1 here, my GCF is going to go on the outside, and then on these inside lines here, I'm figuring out what I need to multiply my GCF by to get what my answer was. Okay? So in this first example, 2x and 8 are the numbers that I have to factor. I have to find my GCF. And easy there, I know that the greatest common factor is 2 because 2 fits into 2 and 2 also fits into 8. Be careful here because only 2x has an x. 8 does not have an x, so I cannot factor out an x. All I can factor out is a 2, so my GCF of 2 gets pulled out. Okay? Then, from there, I need to see what do I need to multiply 2 by to get 2x. Okay, so all that's left is just x, right? Because 2 times x gives me 2x. Then I need to figure out what do I need to multiply 2 by to get 8. And I know that 2 times 4 will just give me 8. Okay, so that's what we're going to do. We need to start getting in the hang and of factoring out a GCF again. Okay, so same thing. We're going to set it up like this every single time. Okay, so looking at 8x and a -4. What is my greatest common factor? What number fits into 8x and 4? Okay, now I know that my greatest common factor between 8 and 4 is 4 because 4 fits into 4 and 4 also fits into 8. Same thing as example 1, only one of my terms has an x, so I cannot factor out an x. Okay, so my GCF in this example is 4. Okay, now what do I need to multiply 4 by to get 8x? And I know that 4 times 2x would give me 8x. Then what do I need to multiply 4 by to get negative 4? And that's simple. 4 times negative 1 will give me negative 4. And that's how we factor out a GCF. So what I want you to do now is go ahead, pause this video, and practice those 3 on your own. When you're done, you're going to press play. Okay? And you'll see me go over the answers. So go ahead and pause right now. All right, so now that you're back, I'm going to go ahead up and set all these up for myself before we do anything. Okay, so every time we factor out a GCF, we could set it up like this. Okay, now looking at 15x and 35, immediately I know that really the only thing that's going to kind of fit, the biggest thing that's going to fit is 5, right? So what I'm going to do is I'm going to pull out a GCF of 5. Not 5x, because only one term has an x, okay? So what do I need to multiply 5 by to get 15x? And I know that 5 times 3 is 15, but there's an x, so I just have to add an x. Then what do I need to multiply 5 by to get a positive 35? And I know that it's just 7. Okay? All right, looking at number 2. I can see that I have to factor 3x and 12. Immediately, I know that my GCF is a 3, right? Because 3 fits into 3, and 3 also fits into 12. Then, what do I need to multiply 3 by to get 3x? And that's just simple, that's just an x. And what do I need to multiply 3 by to get 12? And I know that 3 times positive 4 gives me a 12. Okay? And then the last one, I'm going to break it up. I have 9x and a negative 30, okay? Now, finding the GCF here, right? You know that 9 could fit into 9, but it can't fit into 30. So we know that the GCF is not 9, okay? Then the next numbers that we multiply to get 9 is 3. And I know that 3 fits into 9, and I know that 3 fits also into 30. So 3 is my GCF, okay? Then I'm just going to figure out what do I need to multiply 3 by to get 9x. First, I know that I need to multiply 3 by 3 to get 9. And then I just can't forget there's a little x there. So I'm just going to add on an x. Then, what do I need to multiply 3 by to get negative 30? And I know that 3 times negative 10 would give me a negative 30. Okay? So this is just some stuff we got to remember. We need to be able to factor out a GCF, and you're going to soon learn we also need to remember how to factor easy quadratic equations, okay? So GCF is important, simplification of fractions is important, and factoring is going to be important towards this lesson, okay? So the first page, we just practice simplifying and factoring out a GCF, okay? All right, we're going to move on to the next one. All right, so here is where we are going to go over a rational function, okay? This is the important part. So, the definition of a rational function is a function that is a ratio, and I know that ratio just means division. Okay? If you want me to write it out, I'll actually write it out. A ratio just means a division, okay, of 2 polynomials. Now, we just learned what polynomials were, okay? And they could really be anything. So if you're looking at this example, we have x squared plus 5, which is a polynomial, over x plus 2, which x plus 2 is a polynomial as well. Okay? Looking at this example, it is a rational function because one is divided by the other, just like a ratio. So remember, ratio, rational, division. Rational and ratio are like terms, right? Ratio is actually in the word rational, so that's important. So every time you know that we see a rational function, you're going to divide because there's a ratio, okay? So when we are solving rational functions, okay, I'm going to show you the steps right here. So this first box is super important. We're going to just kind of jump right in. So in order to solve rational functions, the first thing we need to do is factor. Okay, now I'm throwing you back, right? Every time we factor, you're going to have when a equals 1. So I'm going to make it easy on you, okay? Now, if you remember how we factor is the first thing that we're going to do is we're going to multiply. So we have to do it to both the top and the bottom. Okay, that's super important. So on this top here, right, the first thing we're going to do is we're going to multiply A times C, okay, in this example. And here, A is 1, B is 10, and C is 25, okay? So for the, let's say, I'll put the numerator. Okay, we're going to do that here. A times C, in this case, is 25, okay? And then from there, all I need to do is find all the factors of 25. So I know it's 1 and 25 and 5 and 5. Remember, my B was positive, so I only have to list the positive factors, okay? And the only thing from there is I need to pick which factor pair equals my B. So this one's an easy one. I know that 5 plus 5 is equal to 10. So those are the two factors that I'm going to use, okay? Now, when A equals 1, if you remember this, we can just immediately draw two sets of parentheses, okay? And then we're just going to fill them in with the factor pairs that we chose. So for my numerator, we're going to write the end goal here. I'll write it down here, okay? So on the top, I have completely factored, and I chose my factors. So I'm going to have x plus 5 and x plus 5, okay? So that's what I needed to do on the top. Now, I'm going to do the same thing, but I just need to break down the bottom, okay? So I'm going to put here denominator, okay? Remember, A times C. And in this case, I have A equals 1, B equals 9, and C equals 20. So in this case, A times C is equal to 20. So I'm going to go ahead and list all my factors of 20. So I know it's 1 and 20, 4 and 5, 2 and 10. Okay? Then I just need to choose which one of those adds up to B. In this case, B is 9. So I know that 4 plus 5 is 9. So those are the two factor pairs that I can choose. Now, in this case, also, A is 1. So I know that I could just go ahead and write two parentheses with an X in front. Then all I'm going to do is just fill in the factor pair that I chose. Okay? So I have now simplified my rational function. That's what a simplification of a rational function is. But I'm not done yet, because all I've done is factored. Okay? Oh, no. I don't think this is going to stay. No. Okay. I don't know. Give me a second. Hopefully it stays. All right, it's not, so I'm going to read this quick. The next step is, are there any x values that would make the denominator 0? So all that means is we need to use the zero product property on this step. Okay, and we're only looking at the denominator. So for step number, this was all step 1. Now, this is step 2, okay? And we're going to figure out if there's any numbers that make the denominator 0. So how we do that is we just use the zero product property, okay? And that means we're going to set the bottom numbers to the bottom two factors equal to 0, and then just solve. So x can... Well, in this case, x will equal -4 and x will equal -5. But what's important about this is we can't have the denominator equal to 0. A denominator can never equal 0, because when you divide by 0, you're going to get an error message. It's going to say undefined, okay? Or it's just 0. So what we're going to realize here is that when we use the zero product property in this step, what it's actually saying is that x cannot equal -4. And x cannot equal -5. Okay? That's important to realize. So when we're using the zero product property in the denominator, we're trying to find the numbers that the answer cannot be. So our x can never be -4. And our x can never be -5, because it's going to make our denominator 0. And we do not want that. Okay? So, perfect. Now it's stayed. So, here you're going to see. Here, these are called restrictions. So here are my restrictions. I'm going to write them. Restrictions. That's how we're going to call them. My restrictions are that x cannot equal -4 and x cannot equal -5. Okay? And how we know cannot equal is this symbol here. This means that they cannot equal. Okay? All right, and then the last thing we're going to do is we're going to reduce all the common factors. So this is where our simplification comes in. And I told you guys before that this was going to be a little bit different. Okay, because now we're not reducing numbers, we're reducing whole binomials, whole factors, okay? And how we do that, how we simplify my rational functions, is we see if there's anything on the top that looks the same on the bottom, okay? So on top, I have x plus 5 and x plus 5. On the bottom, I have x plus 4 and x plus 5. And here, I can see that this is the same as this, okay? That's like saying 1 over 1. I know that if I have the same parentheses set up the same way on top as on the bottom, they can cross out because they're going to simplify and they're going to cancel each other out. Just like 1 over 1 would just be 1, okay? And then whatever is left is your final answer. So for number 3, my final answer, my final reduction would be x plus 5 all over x plus 4. Okay? And that is how you solve a rational function. That's all that's left. Okay? We're going to do more, but that's what we're learning for today. Okay? So what we're going to do now is we are going to follow the same pattern, but we're just going to do a different example because this one's a little bit different. Okay? Now, on my first step, I'm just going to factor my top and my bottom. Now, on this number on this example here, notice my top, my numerator, is not a quadratic function, okay? It can just be simplified by factoring out a GCF, okay? So that's all we need to do here. So when I look at 4x and 12, I can immediately see and I immediately know that my GCF is a 4 because 4 fits into 4x and 4 also fits into 12. So I'm going to write 4, and then what do I need to multiply 4 by to get 4x, which would just be x, and 4 to get 12, which would just be a positive 3. Okay? So the top's done. I didn't have to factor that. But what I do need to do is I need to factor my denominator, right? Because that's a full quadratic function. So what I'm going to do is I'm just going to do the work over here. So this is my denominator, okay? I'm just going to call it that. So I need to go ahead and list my A, B, and C. So A is 1, B is 1, and C is -6, okay? From there, I multiply A times C, which gives me a -6. Now, I need to list all of my factors of -6. Here is where I need to list all of the different types, right? So I need to list 1 and -6, -1 and 6, 2 and -3, and -2 and 3, because it's negative, so I need both sets, okay? From there, I have to choose my factor pair that adds up to a positive 1, okay? And this factor pair is what adds up, okay? Remember, when A is equal to 1, I could just set up parentheses with x's in the front and then add my factor pairs in. So a -2 and a positive 3. Okay, so that's step 1. I have factored my top and my bottom. Okay, so that's step 1. Okay, step 2 is finding my restrictions. And how I do that is I use the zero product property. Okay, so I'm going to set only my denominator. Okay, you're only worrying about your denominator here. You're only using the zero product property with your denominator. So I'm setting x minus 2 equal to 0 and x plus 3 equals 0. Okay? From there, I'm just going to solve. So in this case, I would know that my answer would be x equals 2. And on this side, I know it would be x equals -3. But what you can't forget is that we are finding my restrictions. So they cannot equal 2. And they cannot equal 3. So x can't equal 2, and x can't equal negative 3 because it would make my denominator 0. Okay, so that's your restriction. So over here, I'm going to write step 2 again. Okay, I'm sorry I don't have enough room. My restrictions, okay, are x cannot equal 2 and negative 3. Okay? We found our restrictions. Then, step 3, we just need to reduce. So, we are reducing this. Okay? So, I'm going to rewrite it. We had 4x plus 3 all over x minus 2, x plus 3. Okay? From there, we are just reducing. So I'm seeing if I could cancel anything out that's the same on top as it is on the bottom. Okay? And I immediately see that I have an x plus 3 on top and an x plus 3 on bottom. So I can immediately cancel those out. Okay? And my answer is just whatever is left. And in this case, it's 4 all over x minus 2. And that would be my answer. Okay? So we have a couple different things we need to do here. We need to factor. We need to use zero product property. And we need to simplify our fraction. Okay? All right? In this case, we also had to factor out a GCF. So these are all things that we've learned already that we need to make sure we know. Okay? Now, my last one here. Immediately, I see that there is no quadratic functions. So I do not need to factor anything completely, right? In this top, there's only one term, so it cannot be factored, okay? It's just 16x. Nothing can be factored. There's no greatest common factor. There's only one term, okay? But on the bottom, we can factor out a GCF because there's two terms, right? And my GCF between 6x and 4 is 2, because I know what 2 fits into 6, and I know what 2 fits into 4. Okay? So, from there, I just need to, what do I need to multiply 2 by to get 6x? And I know that that's just 3x. And what do I need to multiply 2 by to get 4? Plus 2. Okay? So that was step 1. This one's an easy one. That was easy. Step 1. Okay? Step 2 now is to find my restrictions. So I need to use the zero product property on my denom. So zero product property on denom. Okay? Here, all I need to do is set whatever's in this parenthesis equal to 0. Okay? Because that's the only parenthesis we have, so we don't need to use it twice, right? So I'm going to set 3x plus 2 equal to 0. I'm going to subtract my 2. So now I have 3x equals negative 2. And then to get x by itself, I need to divide by 3. So in this case, x cannot equal negative 2 over 3. Okay, so that's my restriction. Okay, there's my restriction there. Step 3 is to reduce. But what you can realize here is that there is nothing the same on top that there is on bottom. Okay, so we are just going to keep it as 16x all over 2 times 3x plus 2. Okay, what we can do though, we're going to leave it like that. We're going to work more on reducing things later on. So you could just leave that one like that there. Okay? So that's our lesson today. We're going to work more on these next time, but we need to start getting in the hang of factoring out GCFs, just looking at things and realizing that there is no factors. We need to get back in the hang of factoring when a equals 1. Okay? So let's work on that. If you have any questions, you let me know.